Alright, so number 9 is similar to what we did in number 6 as far as having a system and having to get one of the variables to cancel out. Again, when you're looking at it, it doesn't matter which one you get to eliminate, either the x or the y. So we just need one of them to cancel. I don't know. We always say pick the one that looks easier. Maybe the y's, the numbers are a little bit smaller. So as it is, 4 and 3 don't cancel. And then so we say, well, could I multiply 3 by something to make them a 4? Well, no, that doesn't work either. So if that doesn't work, then I need to come up with a number that they both go into. Well, they both go into 12. So what I would need is I would need this. I would need a positive 12y on top, and I would need a negative 12y on the bottom. And if I had that, then those two things would cancel each other out. Well, I don't have that, so I got to figure out how I'm going to make that happen. Well, so to make negative 4y a positive 12y, I would have to multiply by negative 3. But the way this thing works is that if you do it to one, you have to do it to everybody, so it's kind of our little golden rule that we got to share there. So negative 24x equals 36. And then on the bottom, we got to figure out how would I turn that into a negative 12. Well, it's a negative 3 now as it is, so if I just multiplied by 4, that would turn it. Now you notice that we set out just to eliminate the y's, and then we're getting into it, and they're like, oh wait, the x's cancel too. So this is one of our kind of special cases of systems. So let's see what happens here. The x's cancel, the y's cancel. So if there's nothing left, our number for nothing would be 0. And then 36 minus 24. Now those don't cancel. 36 minus 24 would give you 12. What we've seen so far is that with systems, just like with the money question of figuring out, okay, who's going to catch up to who with the savings, that they cross at one point. But there's two other possibilities with two lines. Maybe those two lines are parallel, meaning they don't cross at all, so we would have a no solution. Or what the infinite many solutions means is they're actually the same line, in which case it's kind of like one line is on top of one another, and so they touch in an infinite number of places. So 0 equals 12, is that true? Well, no, that's not true. Right, so we would say that this is false. So if you get something that's false, then you would say that there would be no solution. So the example here would be an example of one that would be no solution. If we were to graph these two lines, we would find that those two lines were parallel. Write an interpretation for your answer. It's pretty much what I just said, which is that if we were to graph these two lines, we would say that they're parallel. So these two lines do not cross or do not intersect because they are parallel. Because they are parallel. Alright, so try number 9. I'll give you a little hint. This one was a no solution. I'll give you a little hint. The next one is going to be an infinite many solutions, but make sure you understand why and make sure you're able then to give an interpretation of it. Alright, so go ahead and try number 9. Alright, so let's look at number 9. Number 9 on the right side there, again, I gave you a little hint there, should be infinite many solutions. Again, the explanation there is that the two lines are actually the same line. And so because they're the same line, they intersect in an infinite number of places. Alright, let's move on to number 10.